Welcome, everyone. Before we get started, can you tell us, what exactly is wind energy?
Sure. Wind energy is the process of converting the kinetic energy of moving air into electricity. When wind blows, it carries energy in the form of motion. A wind turbine captures that motion, spins a generator, and produces clean electricity. It uses no fuel, creates no carbon emissions during operation, and the wind itself is completely free and inexhaustible. It is one of the fastest growing sources of renewable power on the planet today.
That is a great overview. But how does a wind turbine actually turn moving air into electricity? What is the core mechanism?
Great question. It works in 3 steps. Step 1. Wind flows across the turbine blades. The blades are shaped like aeroplane wings, so as wind moves over them it creates lift, the same aerodynamic force that keeps a plane in the air, and this causes the rotor to spin. Step 2. The spinning rotor turns a shaft connected to a generator inside the turbine. Step 3. The generator converts that mechanical rotation into electrical energy using magnets and coils. The whole process is elegant, just wind, spinning blades, and a generator.
What are the main physical parts that make up a wind turbine?
A wind turbine has 4 key components. First, the rotor blades, typically 3 of them, each up to 80 meters long, which capture the wind's kinetic energy. Second, the nacelle, which sits at the top of the tower and houses the gearbox and generator. Think of it as the engine room of the turbine. Third, the tower, which raises the whole assembly up to where winds are stronger and more consistent, often 100 meters or taller. And fourth, the foundation, which anchors everything safely into the ground. A great way to picture it, a wind turbine is basically a fan running in reverse. Instead of electricity making wind, wind makes electricity.
What are the main environmental benefits of wind energy compared to fossil fuels?
Wind energy has 3 major environmental advantages. First, it is a renewable and inexhaustible resource. The wind will keep blowing regardless of how much we use, unlike coal or oil which eventually run out. Second, it produces electricity without any carbon emissions during operation. There is no burning, no exhaust, and no greenhouse gases released whilst a turbine is running. Third, it reduces our reliance on fossil fuels, which directly lowers our impact on climate change. Over a full life cycle, wind turbines produce roughly 98% less carbon dioxide per kilowatt-hour than coal power plants.
Are there different types of wind turbines? I have seen some that look very different from the classic 3-blade design.
Yes, there are 2 main categories. The first is the horizontal axis wind turbine, or HAWT. This is the classic design you see everywhere, with the rotor spinning around a horizontal axis and the blades facing directly into the wind. It has the highest efficiency and largest electricity output, and it is used in virtually all utility-scale wind farms. The second type is the vertical axis wind turbine, or VAWT. These spin around a vertical shaft and can accept wind from any direction without needing to rotate to face it. They work well in turbulent urban conditions, are easier to maintain because the generator is near the ground, and are used on rooftops and in smart city projects.
What are the main ways wind power is actually applied and used in the real world?
There are 5 main applications. 1. Utility-scale onshore wind power, large wind farms on land generating electricity for the national grid. 2. Offshore wind energy, turbines installed at sea to capture stronger, more consistent ocean winds. 3. Small-scale and residential wind systems, turbines under 100 kilowatts powering individual homes or farms. 4. Mechanical applications, using wind directly for non-electrical work like pumping water or grinding grain, just like traditional windmills. And 5. Hybrid and emerging applications, combining wind with solar, battery storage, and hydrogen production for even greater efficiency and reliability.
Let us dig into onshore wind farms. How exactly do they work, and how does the electricity get from the turbines to our homes?
Utility-scale onshore wind farms consist of dozens or even hundreds of turbines spread across a wide area of land. Each turbine generates electricity independently. The turbines are all connected to each other through underground cables, which collect the electricity and carry it to a central substation on the wind farm site. At the substation, transformers step up the voltage for efficient long-distance transmission. The high-voltage electricity then travels through the national grid transmission network until it reaches local substations closer to homes and businesses, where the voltage is stepped back down for safe use. The land between turbines can still be used for farming.
Offshore wind farms seem to be getting a lot of attention lately. What makes offshore wind better than onshore, And how do those turbines stay in place at sea?
Offshore wind has some significant advantages. Ocean winds are typically stronger, more consistent, and less turbulent than winds on land, which means turbines generate more electricity more reliably. They also cause less visual and noise conflict because they are far from populated areas. As for how they stay in place, there are two main systems. Fixed-bottom turbines are anchored directly to the seabed with steel foundations. These work in relatively shallow waters up to about 60 meters deep. For deeper waters, floating turbines are used. These sit on large floating platforms moored to the seabed with cables, allowing them to be installed in much deeper water far out to sea.
Can regular homeowners and farmers actually use wind power for themselves? How do small-scale wind systems work?
Absolutely. Small-scale and residential wind systems use turbines under 100 kilowatts to generate local electricity for homes, farms, or small businesses. They are particularly valuable for off-grid locations where connecting to the national grid is expensive or impractical. Farmers in rural areas use them to power equipment and reduce electricity bills. They are also increasingly combined with solar panels and battery storage to create microgrids, self-sufficient energy systems that can run entirely independently of the main grid. The combination is powerful. Solar generates during the day, wind often picks up at night and in winter, and batteries store any surplus. Together, they provide reliable power year-round.
You mentioned mechanical applications, using wind without generating electricity. Can you explain that?
This is actually the original use of wind power, going back thousands of years. Wind energy can directly perform mechanical work without ever being converted into electricity first. The most traditional example is grain grinding. Classic windmills in places like Holland use spinning sails to turn millstones that ground wheat into flour. Another major application is water pumping for agriculture. Wind pumps, the classic multi-blade steel windmills you see on farms, can lift hundreds of liters of water per hour from underground aquifers to the surface, providing water for livestock and irrigation. These mechanical systems are simple, durable, require almost no maintenance, and work completely off-grid.
What are the newest and most exciting emerging applications for wind energy?
There are 4 really exciting developments happening right now. First, wind-solar hybrid farms. Combining wind turbines and solar panels on the same site maximizes land use, since wind often peaks when solar is weakest, giving more consistent total output. Second, renewable hydrogen production. Surplus wind electricity is used to split water molecules through electrolysis, producing green hydrogen that can be stored and used as a clean fuel for industry and transport. Third, bladeless wind turbines. A radical new design where a tall mast oscillates in the wind rather than spinning, reducing manufacturing costs and wildlife risk. And fourth, floating offshore systems, allowing wind farms to be built in very deep water far out at sea, opening up vast new areas.
How do all the pieces of a hybrid renewable energy system actually connect together?
Wind turbines and solar panels both feed electricity into the same system. That electricity can go in 2 directions. It can flow directly to the grid for immediate use, or it can be stored. Storage happens in 2 ways, either in batteries for short-term storage, or through an electrolyzer that uses the electricity to produce hydrogen, which can be stored in tanks for longer-term use. The hydrogen can then be used as a clean fuel for vehicles and industrial processes. When demand peaks and the wind is not blowing or the sun is not shining, the stored energy from batteries or hydrogen is released to keep the grid balanced. It is a genuinely circular, zero-emissions energy system.
Bladeless wind turbines sound fascinating. How on earth do they generate electricity without any spinning blades?
It is a really clever physics-based design. Here is how it works in 4 steps. Step 1. Wind flows around the tall mast-like structure, which is fixed at the base but free to sway at the top. As air passes around it, pressure differences form on either side. Step 2. These pressure differences create a phenomenon called vortex shedding. Swirling vortices of air form alternately on each side of the mast, pushing it back and forth. Step 3. The mast begins oscillating, vibrating rhythmically from side to side. The geometry is tuned so that resonance amplifies this oscillation. Step 4. Inside the base, those oscillations move magnets back and forth through coils of wire, inducing an electric current by electromagnetic induction. No spinning parts, no gearbox, much quieter, and far less risk to birds.
Wind energy sounds incredibly promising. But what are the real challenges and limitations that still need to be addressed?
Even the best green technologies have drawbacks, and wind is no exception. There are 4 main challenges. First, wildlife impacts. Spinning turbine blades do pose risks to birds and bats, particularly in migration corridors. Careful siting, radar-triggered shutdown systems, and new blade designs are all helping to reduce this. Second, noise and visual concerns. Turbines produce a low-frequency hum audible to nearby residents, and some communities strongly object to how they look on natural landscapes. Third, variable energy output. Wind does not blow at a constant speed. When the wind drops, output falls, so wind power must be combined with storage or other flexible sources to maintain grid stability. And fourth, grid integration complexity. Connecting large amounts of intermittent renewable energy to existing grids requires significant investment in smart grid technology, storage, and grid management. These are all solvable challenges, and the industry is making real progress on every one of them.
Thank you for joining us today for this wind energy lesson. This lesson is brought to you by tutorwarren.com, an innovative learning resources platform.